And welcome you all to this video. In this lecture, we are going to discuss probability density function, and this is nothing but the continuation of our previous lecture where we discuss the distribution for discrete case. Here we'll consider the distribution for continuous case. So here you can see we have probability density function, and fx is said to be probability density function if the following conditions are satisfied for f. So fx is said to be probability density function if fx all are non-negative, and second one, here you have integration minus infinity to plus infinity fx dx is equals to 1. Just recall in the case of discrete what we had, that summation of f of xi is equals to 1. So that was our second condition. Here in the third condition, we have probability of a less than x than b is equals to integration a to b fx dx. If these three conditions are satisfied for fx, then it is said to be probability density function. And what about the cumulative distribution function? Sometime in the exam, questions are asked based on this cumulative distribution function, which is denoted by capital Fx. So if x is the random variable, capital X is random variable. So in this case, the cumulative distribution function, that is f of x, it is given by probability of x less or equals to x. That means if you just go with the definition of continuous probability density function, so in that case you would have minus infinity to, here you have see x less than equals to small x, so the upper limit will be x, and here you have f of t dt, and this f of t is what? F of t is probability density function. So from here you can observe one important point, that from here see fx, capital Fx, this is nothing but cumulative distribution function, which is going to be the integration minus infinity to plus x minus infinity to x ft dt. So from here you can just observe this is integration of ft dt. Ft is what? It is density function, density function. So the relation between distribution, cumulative distribution function with density function is this. So in some problem you'll see density function it is given, but with the help of cumulative distribution, they will ask you to find certain probability. All right. So in that case, we need to use this formula. So you just keep in mind that f of x, capital F of x, is equals to probability of x less or equals to x, and this is given by this formula of integration minus infinity to x ft dt. So here, from here, if you just want to derive one formula, that f of x, it is nothing but ddx of capital F of x. So from here you can get this formula, that is the density function, it is nothing but the derivative of cumulative distribution function, just the inverse. If you just apply both side derivative with respect to x, you will get this formula. So keep this one in mind as well and make it a short note. So with this basic understanding of probability density function, now we will move into the questions. So here we have the first problem. This is the first question. Just read this question carefully and try to solve this by yourself first. Okay. If you are not getting, then come here and try to get the idea along with the solution. Okay. So here, what is the question? The shelf life in days for bottles of a certain prescribed medicine is a random variable having the density function this. So density function, it is given like this way: fx, small fx, is equals to this quantity 20,000 divided by x plus 100 cube when x greater than 0 and 0 elsewhere. So find the probability that a bottle of this medicine will have a shelf life of at least 200 days, at least 200 days. So find the probability. This is the question. So basically what you need to find, just pause the video and try to identify the question, what you need to find exactly. So basically probability of, if you just consider the random variable as capital X, so X, at least 200 days. So random variable having the density function this, see, uh, the shell life in days, the random variable, it is given by capital X, suppose. Okay, so it is greater or equals to 200. This is the first part of this question A. So this thing you need to find. So if you just consider this one, what exactly you need to find? If you apply the concept for conjugate, okay, so in this case what you have, 1 minus or complement, if you just apply the concept, if you just apply the concept for complement, so what you have, 1 minus probability of X less than 200, this thing you need to find, isn't it? So basically you need to find 1 minus probability of this one. What will be this? It is nothing but minus infinity to 200. Here you have ft dt. Okay, so from here, 1 minus, see this part you can break it like this way, minus infinity to 0 ft dt plus 0 to infinity, sorry, 0 to what, 0 to 200, obviously it is given 0 to 200, so 0 to 200 ft dt. Now see what you have, 1 minus, minus infinity to 0. What will be the value? See, 0 elsewhere. Only x greater than 0, you will have this part. So here you will have 0. So here you have 0 to 200. And in place of this ft, what you have? 20,000 divided by ft. So t plus 100 power 3 dt. All right, now what you need to do, you just evaluate this integration and you will get, see, this integration you have, this integration. So once you are doing this integration, after solving this, you will get, see, you can either substitute x plus 100 is equals to t and do according to that, or you can simply follow this method, and finally after doing this integration you will get this quantity, which is nothing but probability of x greater than equals to 200 is 1 by 9. This is going to be the answer. So try to do the calculation by yourself. If it is not possible, then you can take help of this. Now the next question it is, find the probability that a bottle of this medicine will have a shelf life of anywhere from 800 to 120. So what you need to find for B? For B, the solution will be, what you need to find? Probability of anywhere from 80. So 80 less than X less than 120. This thing you need to find anywhere from 80 to 120. So this thing you need to find. So here you can see the solution. Here you have, so probability from 80 to 120, so you can include this end point as well, for example 80 to 120. So probability of 80 less or equals to x less or equals to 120. So this thing you need to find. So just follow the definition means the third part, you just see this third part, what you have, this third part, probability of this one, it is nothing but a to b fx dx. All right, now move to the solution part. Here you have 80 to 120 ft dt. So in place of ft, you substitute that function. Here it should be dx. Then perform the integration, put the upper and lower limit respectively, and finally you'll be getting the answer as 0.102. This is the solution for our second part. All right. So this is how we deal the question for continuous random variable. All right. This is our first problem. Now we are moving on to the second question. So again, you have, see, with a cumulative distribution function, the waiting time in hours between successive speeders spotted by a radar unit is a continuous random variable with cumulative distribution function. This is the cumulative distribution function. Remember, what is the relation between cumulative distribution and normal density function? So f of x, if this is the density function, this is nothing but dd of fx. This thing you need to keep in mind. Okay, and also you need to know that you have fx is equals to what? Probability of x less or equals to x is equals to integration minus infinity to x f t dt. These 2 points you just keep in mind. Now, based on this data, that is from this cumulative distribution function, find the probability of waiting less than 12 minutes. Keep this one in mind or observe it carefully. It is given in minute, but the question it is in hour. So convert this 12 minute into hours. Between successive speeders using the cumulative distribution function, using probability density function. These are the question you have. So first thing is convert this 12 minute into respective hour. So what you have, see, you have f of x, it is a given cumulative distribution function, and you need to find probability of x if you convert 12 minute into hour. So what you have, 60 minute means 1 hour. So 12 minute will be 12 by 60. So what will be the value? 0.2. So basically you need to find probability of x less than 0.2. This thing you need to find. And now just go back to the definition. So what you have here, you can say you have f of x is equals to probability of x less than equals to x. See, waiting less than 12 minutes. So basically you need to find from the definition that probability of this one you need to find, which is nothing but f of 0.2. Now apply the definition, that is going to be, what will be the value? What will be the value for f of 0.2? Basically you need to find probability of x less than 0.2, which is nothing but f of 0.2. Now how to find f of 0.2? The first part of the question you need to find this probability by using cumulative distribution function. So you know what is fx, what is fx. Now what is the distribution function, that is f of x? How to find it? Just simply do the derivative for fx, capital F. So if you do the derivative for x less than 0, what you have? 0, because you have this function for x less than 0. So 0 when you have x less than 0, and when x greater or equals to 0, you have this function as 1 minus e power minus 8x. So if you do the derivative, so you will get here the first part will be 0 minus 8 into e power minus 8x. That's what you have here. So 8 e power minus 8x, this thing you have. Now you need to find this one, means integration minus infinity to 0.2. So if you just break it again from minus infinity to 0 and 0 to 0.2, so you'll be getting 0 to 0.2. Here x is greater than 0, so you have this one as the function e power minus 8x dx. So from here if you just do the integration, so what you will have, see, this one you have put upper and lower limit properly, and finally you will be getting this one as the answer. All right, so this is by using the cumulative distribution function part. Okay, so this is for the second question you have. So basically you should keep in mind what it is given, and from there you just need to apply this formula, and according to just do the calculation, and you will get the answer. Okay, and here few more type of question of this continuous random variable you have. See, here you have fx is equals to this one, fx is equals to this one, where x greater than 0 and x less than 0, it is given like this. Find the value for constant c. So in this type of question, what you exactly need to do, just apply the first rule, that is minus infinity to plus infinity. That is actually the second one. This is going to be 1. So now break it properly. So it will be minus infinity to 0. So minus infinity to 0, if x is less than 0, so you have fx as 0. So here the value will be 0, plus 0 to infinity. If you do, here you have what is the value? C e power minus 3x dx is equals to 1. Now here this is 0. From here you need to calculate this, and after doing the integration, what you have, see, after doing the integration, you have simply this one as the answer. C value will be 3. Now the second part for this question, it is just the second part, probability of x greater or equals to 3. Again, you can use the concept for complement. Probability of x less than 3 you need to find. So how to get this? 1 minus probability of this one, how to find? Just pause the video and try it. So what you have, minus infinity to 3 fx dx. Then you can break the integration, and that means minus infinity to 0 and 0 to 3. Then use the proper function, plug the value for c, and then try it. Okay. Likewise, you can solve this fourth question as well. All right. And second question, I think we have missed this second question. Yeah, second question, how to find? Just apply 1 to 2 fx dx. Find this one. So what will be value? What will be value? Here in place of fx, you just put this one. So this is for second part. What will be the value? 1 to 2 c e power minus 3x dx. So plug the value for c and then do the calculation. You'll get the. So you can pause the video, try by yourself, then verify with this solution. Here, this is the answer for second question. This is the answer for third question. See, third part. You can either go with this way as well. See, either you can put here 3 to infinity, then also you will get the answer, or you can just simply apply the conjugate part, x less than 3. Then also it is okay. Can either follow this or this. Here for the third one, again x less than 1, so minus infinity to 1 fx dx, break it, just the same rule you need to apply. This is the answer. So this integration you should do, because this required practice, and in the exam ultimately you need to do the integration. That is the key point. First you apply the formula correctly, then do the integration correctly. Otherwise you will be having wrong answers. So better you can practice this integration at your place. Now here you can see this is another question. This is actually from discrete part. You can take a snap of this question and try this. See the question, whether this fx it is given like this way, it is actually actual probability mass function or not, you need to verify. So in that case the values are 0, 1, 2, 3 and 4. So basically what you need to check, f of 0 plus f of 1 plus f of 2 plus f of 3 plus f of 4, whether this leads to 1 or not. If 1, then it will be probability mass function, and if so, find probability of a1. a1 is nothing but 0, 1. So how to find in this case? Just simply f of 0 plus f of 1 you need to evaluate to get the probability of a1. This is the solution hints I am giving to you. You can pause the video and try the solution by yourself, and then come back, verify your answer from here. Yes, exactly, it is probability mass function, and this is the answer for that probability. Now here see the question, x be random variable with continuous type with probability density function like this. Find the probability for a1 where x lies between 0 to 1. So again the same concept, use the probability for a1 and x lies between 0 to 1. So what you need to do here, integration. Yes, tell integration, anyone? Just do the solution. What do you need to do? 0 to 1, yes. So only 0 to 1 you plug. Hmm? So after that you just use the function properly and you will be getting the answer as 1 minus 1 by e. So try this question. Here this is another standard type of problem. Say here the determine the constant k, the distribution function, it is given like this way. So how to find? Just integration minus infinity to plus infinity fx dx is equals to 1. Break it properly, that is minus infinity to 0, 0 to 1, minus infinity to 0, plus 0 to 1, plus 1 to 2, plus 2 to 3, plus 3 to infinity. And respect function value, you can put here it is 0 dx, here it is kx dx, here it is I think k dx, here minus k plus 3k minus kx plus 3k, here you can put plus here 0 is equals to 1. Do all the integration part by part and add them. Finally you will have one equation. From that you will get the value for k. See here the process, you can check the integration and finally you will be getting k value as half. Okay, and I think that question has see, and the distribution function. See, ultimately you need to find this fx, where you will put the value for k is equals to half. After that you need to find the distribution function fx of the f of x capital. See, so basically you need to find cumulative distribution of the continuous type of random variables capital X. So cumulative distribution you need to find. So find the cumulative distribution. What you need to do, minus infinity to x fx dx or ft dt you need to find. So minus infinity to 0 and 0 to x. You put minus infinity to 0, I guess it is 0, and 0 to x you have the function. So do it according to that. You will get f of x is equals to this one when x lies between this range. Okay, here you can see this formula we used. That's why I'm telling, keep this formula in mind. And finally you need to write fx. What will be fx for x less than 0, for 0 to 1, for 1 to 2, for 2 to 3, for x greater than 3. That means all this part you need to do. That means for, see the question, for x less than 0 you need to find it separately. For x between 0 to 1 you need to find using fx is equals to this, you need to find f of x this one. Similarly for x 1 to 2 using this fx, small fx is equals to k, you need to find this fx, capital fx. Likewise you need to find all these things and ultimately write down like this way. You'll get some function and write down like this way. And this is nothing but the required cumulative distribution function. So likewise, we solve the questions of continuous distribution.